Hello there, we're Team H, and today we're going to be presenting an experiment involving agents in a PEAS defined task environment. The purpose of this experiment is to evaluate how different types of AI agents behave in a vacuum world environment defined by performance measures, explicit environments, actuators, and sensors. We compare simple reflex agents, random agents, and more informed agents to determine how agent design affects performance in a partially observable environment. We hypothesize that agents that incorporate environmental information and perception will achieve higher performance scores than agents that act randomly.
The experiment is based on the concept of rational agents, defined as agents that choose actions that maximize expected performance given their percept history. The vacuum world environment is used as a simplified model to test agent behavior. The agents implemented include a simple reflex agent and a random agent, each following different decision strategies. The main theory regarding the experiment includes agent theory and rationality. An agent perceives and acts with rationality defined as choosing actions for the best outcome. Simple reflex agents. These agents act solely on a simple precept. They make choices primarily based on immediate environmental stimuli. Randomized agents. They introduce chance, aiding exploration, but risking inefficiency. And reflex agents with state. These agents use memory, improving decision making and enabling learning. The experiment was implemented using Python. The vacuum world environment was simulated using two locations that could contain dirt. Multiple agents were tested, including a random agent and a reflex agent. Each agent was executed for multiple simulation runs, and their performance scores were recorded based on their defined performance measure.
This table summarizes the experimental results for both exercises. In exercise 2.11, the environment consisted of two locations, where the agent could move left or right and clean dirt when detected. In this scenario, the simple reflex agent achieved the highest average score because it consistently responds to perceived information from the environment. When dirt is detected, the agent immediately performs the cleaning action, which improves the performance measure. The random reflex agent performs slightly worse because its movement decisions are randomized. While it still cleans dirt effectively, the additional random movements introduce some inefficiency. The random agent obtained the lowest performance because it selects action without considering perceived information. As a result, it frequently performs unnecessary actions and fails to maintain cleanliness. In exercise 2.14, the environment was expanded to a large grid where the geographic boundaries and their configuration were initially unknown. The agent could move in four directions instead of two, making the exploration more complex. Despite the increased complexity, agents that rely on perceived information still achieve high performance, while the purely random agents continue to perform significantly worse.
Experimental results show a clear performance hierarchy among the tested agents. The simplex reflex agent achieved the highest average score, 1906, because its deterministic rules allow it to respond directly to percepts and maintain the environment clean efficiently. The randomized reflex agent obtained a slightly lower score of 17.7524 since its random movement introduces unnecessary actions that reduce efficiently despite still cleaning when dirt is detected. Finally, the fully random agent performed significantly worse, 12.16, because its actions are not guided by environmental information, leading to inefficient cleaning behavior. For the conclusions, the simple reflex agents work well in predictable environments, but lack memory, which can lead to inefficiencies. Randomized agents introduce exploration but perform poorly due to undirected decision making, especially in maze-like environments. The reflex agents with state can use memory to improve decision making and are better suited for complex environments. And overall, memory and structured decision making are key for rational behavior in dynamic environments.